What's up, Algebra 2? So I wanted to post a quick video on tonight's review of polynomials. We're getting ready for a test this Friday, so you guys have been doing pretty well with it. We got one more day of review, and then we're going to see what's up on Friday. So let's jump into it. The first one, number 1 here, says find all the zeros. So I've been really pushing the idea that you can graph to find zeros, and that's where everybody should really start out. When you graph the zeros, or x-intercepts, or roots, or solutions, I guess, all those words mean the same thing. They live on this x-axis here. And so this point right here, when you graph it using a graphing calculator, -2, when you plug in -2, it makes 0, and that's why the point -2, 0 is on the graph. Same thing, 3, 0. 4, 0. So those points are really important for finding those zeros pretty quickly. And so those are the 3 answers from number 1, simply from graphing the problem. Number 2 is a little harder though, so let me move my face out of the way. Find all the zeros from this function, and so when I put it into the graphing calculator, it gives me a graph somewhat like this. So it's an x to the third. That means there's 3 total zeros. 3. So that means that I'm seeing one of them, but the other 2 are imaginary. 1 is real, 2 more, 3 total. That's what we're looking for. So we can use synthetic division to kind of get another polynomial divided out of the given problem. So I wrote 1, 5, 9, and 45. Those are all the coefficients from the given polynomial. And then -5 was seen to be a 0, so I put -5 here on the outside, and I put 0 at the end before I even started, because I know that that's like a targeted value, since I know that -5 goes in and makes 0, no remainder. So drop, multiply, add, multiply, add. I'm going to drop 1, multiply by -5 to get -5, add the 2 together vertically to get 0. -5 times 0 is 0. 9 plus 0 is 9. -5 times 9 is -45. 45 plus -45 is 0. So I just essentially divided by x plus 5. Okay, if you were doing this with long division, x plus 5 is a factor. X minus 5 is the 0 for that. So I basically divided this given polynomial by x plus 5, and what comes out was x squared plus 9. And so I can see that because if it was dividing x to the third by x, those powers subtract, and so this first one represents 1x squared. The middle one is my linear term, but it's 0, so I don't have a linear x value here. And then 9 is my constant. So you see these arrows going down. I'm turning this polynomial, these coefficients, into a polynomial. Now this one's actually a little easier because I don't have to use the quadratic formula, as long as you understand that you can solve using square rooting. So I'm trying to find the zeros that are imaginary. So I subtracted 9 to the other side, making it negative on the right. And then when you square root -9, you get plus or minus 3i. It's an imaginary value, so you have to have I there. Okay, so the next problem is actually a lot simpler. It says, how many zeros will this polynomial have? Do not find them. Well, guess what? The power, the highest power, tells me how many total zeros there are, so that has to have 9 zeros. We're not actually solving them. I'm just looking at the power and saying, hey, there's 9. So many are real, so many are imaginary, but together that total number of zeros should be 9. Similar to this one, it was x to the third. And so that meant in the end I needed 3 answers. There's 1, and then this one actually counts for 2, 3i, and -3i. This one had 3 zeros, and they were all real. Okay, so just a quick reminder that you can tell by how many zeros one will have based on the highest degree, highest exponent, highest power, whatever word you know that to be. So another thing I've been really pushing, because I really think that once you master this skill of looking at a polynomial and understanding what the general shape looks like, you take your algebra understanding to like all new level. So x to the fifth, okay, it's an odd. That means you're going to have one that's facing down, and you're going to have one that's facing up. Okay, kind of like a line. X to the first power is a line, and it's just like this. One's going up, one's going down. But as soon as you make one even, like x squared, they're either both up or they're both down. So we've been talking a lot about this. So this is positive, and so I wrote these numbers in here just to kind of talk about how you know how to sketch it. So the idea is that it goes up, that's 1, it goes down, that's 2, it goes up, that's 3, it goes down, that's 4, and it goes back up, and that's 5. So there's like 5 directions in the polynomial. So I went ahead and set up the idea of end behavior for you. And so when you're talking about x moving left, you're talking about as x approaches negative infinity. And as you're talking about x approaching the right, that's really talking about x going towards positive infinity. So your answer should go right here, and it should be some form of either infinity or negative infinity, and it's based on what's happening on the left and what's happening on the right. Same thing for number 5. Actually, these answers are the exact same, and we'll talk about them tomorrow. Fill in what should be in blue, that blue box there. Go ahead and put what you think should be there, but your answer should look very much like this. Okay. All right, so the last one I just kind of set up. I'm only going to do one of them, and then I'll let you try another one just completely independently. And so yesterday when we did homework, I just kind of put what the process looked like as a whole. Today I'm going to walk you through that once. Alright, so when I'm looking at this and I'm wanting to start long division, I think n to the third divided by n. First of all, 1 divided by 1 is 1. But when I divide powers like this, n to the third divided by n, you really use subtraction. So this should be n squared. Okay, it is kind of hard for me to write on my iPad here, so if it looks sloppy, I apologize. So now I'm going to distribute to what I'm dividing by, so I can get two numbers right here. N squared times n is n to the third, and then n squared times negative 2 is negative 2n squared. Okay. Now this part can be a little tricky, and I keep trying to talk about it. You are subtracting each of these. The first one is not that difficult because people pretty much know that it's going to cancel. But I'm really subtracting this one as well, and so minus a minus really changes this sign to be a plus, and you just really got to be careful about that as you're doing it. So this ends up being 9n squared. So I pretty much divide the first terms, put my answer at the top, I distribute and I subtract each part, and then I need to repeat that process by dropping the next term down, minus 25n. And so I want to repeat the process again. I'm thinking 9n squared divided by n. So first I think 9 divided by 1 is 9, so I'll put a plus 9 here. And then the powers do subtract. 2 minus 1 is 1. And I was telling a student this morning, these powers should kind of count down. So if the first one is n squared, the next one is just n, and the next one should be a constant with no variable at all. So let's distribute 9n times n is 9n squared. These should match every time you start your distribution, or that means you didn't pick the right number up here. And 9n times negative 2 is negative 18n. And so again, I'm going to subtract each of these. So the first one's a little easier because those cancel every time. But here you're really subtracting, and so minus a minus really makes that a positive. Okay, it just always changes the second sign basically. So negative 25 plus 18, it's got an n with it, so I'd say that's negative 7n. One last time, let's drop this number down. You get 13 here. And I repeat the process one last time. So negative 7n divided by n is just the negative 7 because the n's cancel out. N divided by n is 1, or the 1 minus 1 powers is 0, so you have 0 n's when I write this part. And so I'm going to do another distribution. Scroll down just a little bit. Negative 7 times n is negative 7n, and negative 7 times negative 2 is positive 14. However, you must be careful because yes, you are subtracting this. Minus a minus ends up making that a plus, so those cancel. But like I keep saying, you're really subtracting, so that is not really adding, that is subtracting. And 13 minus 14 is negative 1. So once I get to the end and there's nothing else to drop, this becomes our remainder. Because this number is not 0, it means that n minus 2 is not a factor of n to the third and all that other stuff. If you ask me to factor this first one, I don't know if it's factorable or not, but n minus 2 would not be a part of it because you have this 0. So I'm going to go ahead and say that it's a minus 1, but just like when you do other divisions, you have to go back and put what you were dividing by. And so that is how I complete my answer. So I want you to try this one on your own. We got to get as much practice in on something like this as possible because it can be tedious. You can always double check your answer using synthetic division, which I think I will demonstrate on the first one real quick. Alright, so if I want to check my answer, I need to think about what made this 0. A lot of students would just take that -2. You can't do that, so I'm going to actually divide by 2. Always use the 0 of whatever you're dividing by. So it looks like I had 1 into the third, 7n squared, -25n, and then a 13. And I'm going to go ahead and put my targeted remainder at the end as -1, because if I did this correctly, I should get that same remainder. Alright, so let's give it a shot. If I can get that to go away. Let's try to drop the 1, and that really matches this one. Let's multiply, so 2 times 1 is 2, and then these add to give you 9. And guess what? That matches this 9 right here. And then 2 times 9 is 18. When you add these together, you get -7. That matches this -7. Isn't that just so cool that it works like that? 2 times -7 is -14, and guess what? 13 plus -14 is -1. So I definitely got that correct. Alright, so use that on the test to know that you did it correctly, or maybe that can really assist you in demonstrating the process, because I do have to test you on the process. So good luck tonight. Hope to see you all have the homework tomorrow with a lot of questions for anything that we covered in the chapter, and see you tomorrow. Peace.